So we're looking at the mechanism now for the reactions of the acyl chlorides, and the reactions were in the last video. And again, it's better really to kind of go to a page here and just have a look at each one of them in turn, and you'll see that, you know, even though the reactions are the same, the mechanisms are also exactly the same. Okay, so remember from last time we've got water, alcohol, ammonia and an amine to go through. So I'll do the mechanism first and explain all of that, and then I'll change bits of it so that you can see that it's exactly the same, whether it's water, alcohol, ammonia or an amine. Okay, so obviously the key thing in here to kind of have a look at what is going on is to put your dipoles on. So we have a D minus there, D minus here, and a D plus carbon. And remember, the oxygen on here is D minus, and the hydrogens are going to be D plus, okay? So what we've got is the D minus oxygen in water being attracted to the D plus carbon in the acyl chloride, and that is our first curly arrow from the lone pair there to the D plus carbon. Because it is donating a pair of electrons to form a dative covalent bond, the water is behaving as a nucleophile. So this type of reaction is nucleophilic. Okay, and we'll look at the rest of it in a moment. Now, the D plus carbon has got 4 bonds. It can only have 4 bonds. So if I form a bond, our bond has to break. And the one that breaks is going to be the weakest. And we know already that double bonds are weaker than single bonds because of the less efficient overlap of the p orbitals. So the carbon-oxygen pi bond, that second bond, is going to break. Where do the electrons in that bond go? Well, the oxygen is electronegative. It's pulling on them anyway, so it's going to go to the oxygen, which means I have a curly arrow going from the middle of that bond to the oxygen there. What we now need to do is have a look at what we've got. So I've got my R group still. I've got my carbon here. My chlorine hasn't changed. Up here, I've got an oxygen. I'm going to put those lone pairs on there. Now remember, oxygen has got its own electron back, plus an extra one that the carbon are put in the first place, which makes this oxygen negatively charged. What we've put on here is water, so let's put the water on there. And again, if you think about the bond that has formed, oxygen has given an electron that it normally would, plus an extra one, which basically means it's lost an electron, making it positively charged. Okay. So at this point here, this is our intermediate, and I hope you can see that what we've done is we've added water to that molecule. So the kind of next part to this is nucleophilic, it's addition, okay? And what we now need to do is have a look at what happens next. So, and there's 3 arrows that you would need for 1 mark here. So there's one from there to there, which reforms the carbonyl. Okay, we lose our chlorine. Now we know we always lose our chlorine, and we know that we always lose a hydrogen. So the hydrogen pair of electrons go back onto there, which then gives us our final product. So R, C, O. The chlorine has come off, and I've got O, H, and then I've got H plus Cl minus, or you could write that as HCl. Okay, so I hope you can see that we've eliminated the HCl in this kind of second stage of things. So what we've got here is a nucleophilic addition elimination mechanism, and this mechanism, and you're going to see that when I start changing it, is identical for water, alcohol, ammonia and the amine. So that's the one with water, and what we're going to do now is I'm just going to change it so we've got the mechanism for the alcohol. Okay, now if this was an alcohol, one of the hydrogens there would now be an R group, which means this hydrogen over here now becomes an R group. Actually, let me swap that round because we've kept that hydrogen on someone that goes. So let's put that hydrogen back, and we'll make this one the R group, so that when we go over to here, we've got the correct hydrogen coming off. I've got my R group there. And I hope you can see that what I've made now is my ester and hydrogen chloride, because I've now used an alcohol instead of water. In the previous video, we said that ammonia and water are pretty much the same molecule, so I'm just going to swap those around as well. So I'm going to try and get rid of that in there, get rid of the oxygen from there, and get rid of that oxygen there. And what I'm going to put in its place is, just get rid of that. What I'm going to put in its place is a nitrogen. Now, because this is ammonia, we're going to have 3 hydrogens coming off there. So let's put that nitrogen in. Let's put the nitrogen in there. Put the hydrogen here. Of course, because it's ammonia, I'm going to have another one. So put that hydrogen there. Hydrogen. Hydrogen. So over here I've got my nitrogen, hydrogen, and hydrogen there. So let me just talk it through again. All right. So my lone pair of electrons here on the ammonia form a dative covalent bond with the carbon. The pi bond in the carbon R group breaks and the pair of electrons go to the D- oxygen. We then have the intermediate, which is this step here. Okay, so my ammonia has been added, so that's the addition part of the reaction. And then a pair of electrons from the oxygen reform the carbon R. The chlorine leaves, one of the hydrogen leaves, putting the pair of electrons back on the nitrogen over here. Okay, and then I've got my 2 hydrogens on there. Now that's not very clear. Let me just put those 2 hydrogens on a little bit clearer. So hydrogen and that hydrogen there. And that's what makes the amide, if you remember. Okay, so that's the third one. The fourth one is the using a primary amine, and the primary amine, remember, the only difference is the one of the hydrogens here, one of the hydrogens there, one of the hydrogens here is now an R group. So R, R, R. So I've now got exactly the same mechanism, but I've now got my N-amide. And if you look at what I've done here, I haven't changed any of the red arrows at all. The only thing that has changed is the oxygen has been replaced with a nitrogen. It's a lone pair. It's D-, does exactly the same as the oxygen does. And I've changed the hydrogens either in water for an R group to make an alcohol, or one of the hydrogens in ammonia with an R group to make an amine. So when we have a look at this on here, I mean, what I've got here really is the summary. And I wouldn't worry too much about that if you understand the mechanism. So here's the mechanism that we talked about with water. Okay, so we've got the curly arrow forming from the water to the carbonyl, and then the carbonyl bond breaking. We then get our intermediate here, and then we've got our 3 arrows, which then give the carboxylic acid and hydrogen chloride. That's with water. With water, if you look at the kind of red hydrogen that we've got in the mechanism there, if I now change that for an R group, you'll see that the mechanism is identical. So just as before, lone pair from the oxygen form a dative covalent bond with the D+ carbon. The pi bond breaks with the electrons going to the D- oxygen. We get our intermediate form here, We've then got our 3 curly arrows, but because our hydrogen is now an R group, we make an ester and hydrogen chloride over here. If I replace my kind of alcohol, or if you want to think about it, water, with ammonia, then I get this one. And again, exactly the same. Pair of electrons from the nitrogen this time form a bond with the D plus carbon. The pi bonds, the carbon-oxygen pi bond breaks, and the pair of electrons go to the D minus oxygen. My intermediate forms here. I've then got my 3 curly arrows, which then gives me my amide and my hydrogen chloride. And again, if we look at one of the red hydrogens as we move on to the 4th one, which is with a primary amine, when we get to this one here, again, you can see that I've got an R group now instead of a hydrogen. Exactly the same mechanism. Pair of electrons from the nitrogen to the D plus carbon, pi bond breaks, electrons go to the D minus oxygen, intermediate formed here, and then our 3 curly arrows, which now gives us our N-amide and hydrogen chloride there. Okay, so this is the mechanism for the reactions that we did last lesson, and I hope you can see that because the reactions are identical, the mechanisms are identical. The only thing that changes really is either an oxygen or a nitrogen, depending on where we're looking at waters, alcohols, or ammonia and amines, and then a hydrogen with an alkyl group as we move from water to alcohols and ammonia to amines. Okay?